So we're continuing on with this examination of triangles and whether they're similar or not. Remember, similar means they're basically the same shape, but they're stretched or shrunk. So the way I'm going to do this is I'm going to compare different sides of the triangle on the left and the triangle on the right. And we're going to start off with the short side. So the triangle on the left has a short side of 5, and the triangle on the right has a short side of x. Now I kind of like to have my x on top. I think it makes things easier. So I'm going to put x on top, and I'm going to say, let's compare the x against the 5. And that comparison in math is called a fraction or a ratio. Now we're going to do a similar comparison, but with the long side. So I've got 15, and I'm going to compare that to 11. The trick with this is you have to make sure that if you're picking the triangle on the right to be on the top of the fraction, you have to be consistent. You can't go mixing that up. So now I've got an equation here, and I can solve that. That's x over 5 equals 15 over 11. Well, how do we solve that? We multiply each side by 5. So those 5s are going to cross out, and you get x equals whatever 15 over 11 times 5 is. And if I plug that into a calculator, I'll get 6.82 or so, right? So that would be my answer. That's the length of side x. And a good thing to ask yourself when you're about to be done with the question is to say, does this make sense? And if we look at this situation here, we see that 11 got bigger. Not huge, just a little bit bigger. And did the same thing happen to the number 5 when it went to 6.82? Yeah, I'd say that looks a little bit bigger, maybe a third bigger or something in that ballpark. So that's how you work these problems through.